The topic is estimating partial derivatives using the algebraic formula. Alright, so let's do this example. Let f of xy equal xy squared. Use the difference quotient to estimate partial derivative with respect to x of 1, 2. Alright, again, here's the definition. So what is fx? The estimation of partial derivative with respect to x of 1, 2 is almost equal to f of a plus h. In our case, my a happens to be 2, right? And the b happens to be, a happens to be 1 and b happens to be 2. So it's f of 1 plus h. My h happens to be 0.1 minus f of ab, which means f of 1, 2 in our case, over the h is 0.1. Now, fx of 1, 2 is almost equal. 1 plus 0.1 is 1.1. Oops, it's 1.1, and then I need to write the b. The b is 2, and then close parentheses. This is a comma. So 1.1 and then 2 minus f of 1, 2 over my h. Now this is about equal. Now I need to plug 1.1 here and the 2 into y. So what that would be 1.1 times 2 squared minus, right? And then f of 1, 2, I plug 1 into x, 2 into y, so 1 times 2 squared. Then all that over 0.1. So what would that be? 4.4. This is going to be 4.4 minus 4 over 0.1. Use your calculator, would be 0.4 over 0.1, which is 4. So it's about 4. Now let's for question B, you need to calculate fx of 1 over 2. Remember, if you want to calculate fx of 1 over 2 without estimation, then you need to take a limit of this quantity or do it the shortcut. Shortcut will be what? Fx of any xy will be partial with respect to x of this function. Now remember, we take y to be constant, so this will be y squared partial with respect to x of x, which is 1, y squared times 1, which is y squared. And now this means that fx of 1, 2 will be y squared, means 2 squared, which is 4. So actually, the estimation, compared to the estimation, we're usually hoping to have them almost equal. In this case, they happen to be even equal to each other. The estimation and the actual partial derivative. This is the actual one, partial derivative at that point at 1, 2, and this is the estimation, exactly the same. But generally they're not. We'll see how it's going to happen for C. So for question C, use the difference quotient to estimate fy of 1, 2. Again, fy, partial derivative with respect to y of 1, 2 is almost equal f of 1, right? We're using this formula now, f of 1, then b plus h, so 2 plus h, my h happens to be 0.1 again, right here, 0.1, minus f of ab, which is f of 1, 2, divided by h. Now this is almost equal, all I'm doing, I'm adding 2 plus 0.1, so that would be f1 2.1 minus f1 2 over h. Now fy of 1 over 2 is almost equal, what is f of 1 2.1? Plug it into the original function. That would be 1 times 2.1 squared minus, and then f of 1 2, we already did it, plug it also in the function, so 1 2 squared over 0.1. Now this is going to be equal 0.41. Use your calculator over 0.1 which is equal to 4.1. So Fy of 1 over 2 is almost equal to 4.1. So let's do the actual, let's calculate a partial derivative with respect to y of 1, 2. Now partial derivative Fy of any xy is going to be partial with respect to y of our function xy squared. Now x is constant, take it outside. Partial with respect to y of y squared. So it's x, and then the derivative will be just 2y, which is 2xy, right? Now Fy of 1, 2, plug the 1 here, the 2 there, right? Plug 1 and 2. So it's 2 times 1 times 2, which is equal also 4, right? So comparing it, these are almost equal, right? Almost equal. So in other words, yep, estimation, you're right, almost equal. It's a good estimation. And that's it for this example.